Press the subscribe button and click on the bell icon for latest technological and educational updates. First educational video, and that's of physics. And so we are going to follow basic science. Our first chapter would be time, motion and speed, chapter number 6 of basic science, class 7, and it would be of page number 47. So pause the video and quickly open your basic science and follow me. So let's start. Imagine a timeless world, one day rolling into another, months slipping by and years unaccounted for. What do you think would be the greatest problem in such a world? How would you know when to reach school? How would anyone know when a train or plane would arrive at or leave a place? How would you know when the summer vacation starts? Yeah, these are some, questions, and you can answer these in a comment box and share your experience. And we move to our next topic, that's measuring time. Most likely this is why people felt the need to measure time, to be able to communicate and coordinate with each other, to be able to match times and do things together in a systematic way. So if somebody asks you, why did people feel to measure time? You could give the answer, people felt to measure time to be able to communicate and coordinate with each other, and to be able to match times and do things together in a systematic way. You have learned in your previous class that in order to measure something, we need to have a unit of measurement. Now, what is this unit of measurement? I'll give you the book definition. That's a unit of measurement is known as a fixed quantity with which we compare an unknown quantity we wish to measure. So, I'll give you an example. If you have visited a market, they use a beam balance to measure the vegetables and something like that. Suppose I bought 1 kg of ladies' fingers. How does the retailer measure that 1 kg of ladies' finger or 2 kg or 5 kg, etc.? He has a particular weight. If you have seen, he will have a particular stone weight that weighs around 1 kg, or there are different types of measures, 500 gram, 1 kg, 100 gram and something like that, but most commonly they use the 1 kg one. Now let's give us the definition. A unit of measurement is known as the fixed quantity with which we compare an unknown quantity we wish to measure. So what is the fixed quantity here? The fixed quantity is the weight that they are using, and that's of 1 kg. That's a fixed quantity, that's a known fixed quantity, right? And the unknown quantity we wish to measure is the lady's finger, because the retailer does not know that how much lady's finger is he giving to us and how much would he give. So they use the units. Now let's move on to the next line. It's easy enough to fix a certain length or mass at a standard against which to measure other lengths or masses. But how does one quantify time or fix a portion of it? The only way to do it is to choose the time interval between two events as an unit of time. So before we learned that we use the kg or the weights for measuring mass, and of course you know that we use meter, kilometers to measure length. That's also easy to fix an unit. But what about time? The only way to measure time is by measuring the time interval between two events, and that would be a unit of time, that would act as a unit of time, and that would be followed universally. What should one keep in mind while choosing events with which to mark a portion of time? That the events occur at regular intervals of time. What is regular intervals of time? We'll learn in the next topic, that's the periodic events. An event that occurs at regular intervals of time is called periodic. Suppose the waning and waxing of moon. I hope you have heard of it. The new moon, or the new moon, or that full moon, they are the waning and waxing of moon. Why should one choose a periodic event to fix a unit of time? This is a good question. They have given one example. Let's go for it. Let us take the barking of a dog as an example and as an unit of time. That's really funny. That event is not periodic. There would be no way to fix this quantity. It would keep changing since dogs do not bark at regular intervals of time. So, this is a funny thing that if you go to a dog and tell him that you would bark at 1 second each intervals, will the dog listen to you? No, he won't. He would bark when he would like. Most likely, the idea of using periodic events to measure time occurred to people by watching nature. That's a really important thing. Many natural events like the rising of sun, the waxing and waning of the moon, as I said, and the changing of the seasons are periodic. People down the ages have used the rising of sun to measure a day. In many civilizations, the interval between one new moon and the next was taken as a month. In general, the cycle of season was used to mark as a year. I hope you understood that, and next we will move to our subtopic, that's the sundials. Now, what do you mean by sundials? You may be thinking, sundials? Is sun dialing a phone number or what? No, that's not like that. Sundial means, and dial is set, and as the sun moves, the reflection shows us the time. We'll go on with this topic and let's read. How did people in the olden days measure intervals of time shorter than a day? One device they used was the sundial. It had a triangular metal plate fixed vertically at the center of a circular plate. The device was placed in the sun with the triangular plate known as the gnomon along the north-south direction. So it was kept in the north-south direction, by the way. The positions of the shadows cast by the gnomon at the different times of the day was used to mark the time on the circular plate or the dial. So if somebody asks that what is the structure of a sundial, you would have to give the answer like this. Next we move on. Sundials can tell the time quite accurately, but the problem is that they cannot be used after the sunset, as there would be no sun actually, so sundial would not have any value after the sunset, nor they can be carried around. If they were carried around, the sunlight, actually the earth is moving, so the sun's position is not equal for each and every place, so there would have and change there, so it would not be possible to carry it around. Some other devices used by the people in older times was candle clocks and hourglasses. Now here is an example that's not of very value, and they are gonna make a sundial, and that's not sundial, right? They're gonna make a sundial and hourglass. We don't need to make that. I think you have heard of the sand clock, right? There's something like that. So let's move into our next topic. That's a pendulum clock. What is a pendulum? A pendulum is a weight hung from a fixed point in such a way that it can swing freely. Who invented the pendulum? Can you say it? Yeah, I guess some of you have given the correct answer. That's Italian astronomer Galileo Galilei discovered the motion of pendulum is periodic. In other words, a swinging pendulum takes a fixed time to complete an oscillation, one to and fro motion. This was put to use by the Dutch scientist Christian Huygens to make the pendulum clock. The pendulum in such a clock takes 1 second to complete an oscillation. Now, some of you have a question in mind that if I swing and bob freely in the air, after some time it will stop, and I am sure that the motion of the pendulum will decrease. Yeah, that decreases. But why does it decrease? Because of friction in the air. And a gravitational force obviously resists it, but not too much. But the friction in the air opposes the motion of the pendulum. So let's read an activity. If you have done this activity in your previous class, perform a little differently this time. Find the time taken by the pendulum to complete one oscillation. The simplest way to do this is to note the time taken by pendulum to complete 20 oscillations and then to divide the time by 20. Repeat the activity thrice and find the average of 3 results. It's always advisable to make 3 observations and to take an average of the 3 to avoid errors. Now change the length of the pendulum and find the time it takes to complete one oscillation. Does the time change? No, it would not change, but it would change in practical life. But I don't think that it would change in this experiment because they have a fixed air content. If I'm not wrong, you would have a question about why does the pendulum of the pendulum clock clock's oscillation remains same, that's 1 second, because no external air can get inside that clock's pendulum, so it is not affected by the air and it moves smoothly. And there's something battery also helping that, by the way. And next we have the time period of a pendulum. What is the time period of a pendulum? The time a pendulum takes to complete one oscillation is called its time period. It depends, among other things, on the length of the pendulum. For a particular length, the time period does not change with the displacement of the bob, the weight, from its position of rest. That is why that is provided to you not to pull the bob too hard. We have heard of it. And next, that is, what is frequency? The number of oscillation a pendulum makes in 1 second is called a frequency. Or we can define a frequency as f equals to 1 by t. That means frequency equals to 1 by time period. Yeah, that's correct. And it also depends in gravity. You can tell that the time period of a pendulum is inversely proportional to 1 by gravity. Now, if you have some questions with gravity, I'll tell you some important points. That gravity changes with the position of the earth. What is gravity actually? Gravity is the force exerted by the center, from the center of the earth to that means the gravity is the force that is exerted by the earth pulling the things that are present in the surface of the earth to the center of the earth. Yeah, there's an exact definition. I'll leave it that way. And you must have questions that why gravity is related to the time period. Now I'll give you 2 important points, that are the equatorial radius and the polar radius. What do you mean by these? The equatorial radius, as you know, is the radius of the equator of the earth, and the polar radius is the radius from North Pole to the South Pole and something like that, and that's the polar radius. And as you know, the earth is geoid or bulging at the center. That means the equatorial radius is more than the polar radius, right? So the places near the equator have less gravitational force, while the places in a polar regions have more gravitational force. So if you go to a polar region and move a pendulum, obviously that would be different from the pendulum that is being swung in the equatorial region. So we are not gonna discuss with this topic, as this is not in the syllabus, but still knowing is good. And next we move on to the next subtopic, that's the units and the symbols. What is the SI unit of time? It is second. Everybody knows that. Its symbol is small s. By now, you know the units of several other physical quantities like the mass, length, and temperature. You must remember the following rules while writing units or the symbols. So they have given 3 rules that are used to write the symbols and something like that. The name of a unit always starts with a small letter. This is absolutely correct. You go on with meter, kilometers, seconds, etc. It will start with a small letter. The only exceptions to this rule are Celsius and Fahrenheit. Actually, Celsius and Fahrenheit are the units that are made by scientists, and the units that are all of the units that are made up of scientists are starting with a capital letter. Not only Celsius and Fahrenheit. Actually, we write it as degree Celsius and degree Fahrenheit, by the way. The symbols of units are written in small letter except the case of the units which are name of scientists. That I told you here in the first point also. These were the do's, and what are the don'ts? Never put a stop after the unit of a symbol and never use the plural with a symbol. We should write 90 kg, not 90 kg full stop, or 90 kgs. That should not be written. Only 90 kg should be written. We use the plural while we spell the unit. Yeah, that's a common thing as we spell that 10 seconds. But when you write it, it would be 10 SEC. So this was the subtopic units and the symbols. Then we'll move to the next subtopic, that's the measuring time intervals. Perhaps you remember that mechanical clocks and watches make use of a balance wheel, and electronic watches use the natural vibrations of quartz crystal to keep time. This is an important thing, that mechanical clocks use that, balance wheel to measure that, and electronic watch use the beat of the quartz crystals, natural vibrations actually. Some clocks and watches, however, mark the passage of time continuously. They cannot be used to measure the time intervals. Stop clocks, stopwatches, and electronic stopwatches, on the other hand, have switches which they can be started and stopped at will. They are used to measure time intervals during scientific experiments, sport events, and so on. Now, if you have opened page number 50, you would get to see the diagram A and diagram B. Figure 6.4 A, that's of a stop clock, and figure 6.4 B, that's of a stopwatch. So that was it, and then we'll move on to our next topic, that's the motion and speed. I hope you understood all about the topic measuring time. Okay, now we'll move on to motion and speed. Now, I hope all of you have seen cars moving by, and in Kolkata now there has been some rules that a car should not be driven at a speed of something and something like that, at the speed of very high speed or something like that. But have you ever thought what is speed? We'll go on with that later, and let's start the chapter. Our body is said to be in motion if its position changes with time. What do you mean by its position changes with time? Its position changes with time means that if a car A is at a position 1, it would change its position to position number 2 if the motion of the body changes. So, a body is said to be in motion if its position changes with time, and it is at rest if the position does not change with time. To be able to describe the motion of a body, we need to know a few things about motion. One of these is its speed. Now talking about the speed. The speed of a moving body is the distance it travels in unit time. I would simplify the definition as the speed of a moving body is the distance it travels in a particular time. In other words, the speed of a moving body is the distance it travels divided by the time it takes. So that's the formula. Distance, that's unit is meter, and time, that's units is seconds, equals to speed, that means meter per second. That's the unit of speed, meter per second, kilometer per hour, and something like that. You have surely heard of a kmph, kilometer per hour. That's the speed used by the cars in most cases. So this is something like that. Now we'll move to the next topic. That since the SI unit of the distance, that is meter, and that of the time taken is second, the unit of speed is measured in meter per second. That's the SI unit of speed. You need to remember this. However, when we talk about the speed of cars and trains, we generally use kilometers per hour or km by h. Km by h, that slash can be defined as per also, right? So I'm gonna give you some examples about this, about motion actually. Suppose you and your friend are sitting in a bus and your father is standing outside the bus in the ground and the bus starts to move. Your father looks at your friend and tells that he is moving, but you, when look at your friend, tell that he's not moving. No, he's not moving, not at all. So who is correct? You may think that your father, he's more experienced than you, so he would be the correct one. Or some of you may think that the ground is the main thing, so it is moving. You would tell like that. But if I tell that both of you are correct, motion can be defined according to somebody. That's a must for motion. Your friend was moving according to your father who is standing at the ground, and your friend is not moving according to you who is in the same motion with your friend. If your father looks at you also, you tell that you are moving. And if you both look at your father, then you would also tell your father is moving, but actually you are moving. So, motion can be defined only by according to somebody. I hope you understood this. Now we'll move to uniform motion and non-uniform motion. If the speed of a body moving along a straight line remains constant or does not change with time, we said that the body is in uniform motion. If the body changes its direction or motion of its speed changes with time, it's no longer in uniform motion, its motion becomes non-uniform. Right, it would become a non-uniform motion. So there are some examples here. A school bus takes 45 minutes to cover a distance of 18 km. Calculate its speeds in kilometer and meter per second. So 45 km equals to 45 by 60 hour equals to 3 by 4 hour. Distance covered equals to 18 meter. Time taken equals to 3 by 4 hour. Therefore, the speed equals to 18 by 3 by 4 km per hour. That's 18 into 4 by 3 km per hour. That is equals to 24 km per hour. And let us express this in meter per second. They have not mentioned here, but this is actually the conversion of the unit of speeds. Distance equals to 18. So we have to break that up first. What do you mean by 24 km per hour? That means that you have calculated the speed as it is in kilometer per hour. So for calculating that speed, you have used the distance covered and the time taken. So for that, distance will convert it to that measuring unit, and it would be 18 into 1000 meter, and time will be 45 into 60 seconds. Therefore, it would be 18 into 1000 meter by 45 into 60 seconds. That would be 6.67 meter seconds. Meter seconds mean meter per seconds. You can use in short form also. Meter per second actually means m by s, meter by seconds. So it could be written as meter and second to the power -1. The motion of a bus on the road is not uniform. The bus continually changes its directions and its speed is not uniform either. It slows down, stops at traffic lights, and the bus stops, starts again and picks up speed. So, the speed you have calculated is generally the average speed of the bus. This in fact is true of most real life situations. Generally, when we talk about speed, we mean average speed. So if somebody tells you what's the difference between average speed and normal speed? Speed means, as you have learned the definition, distance by time equals to speed. But the formula of average speed is the total distance divided by the total time taken. That's the average speed formula. There are some examples, you can just go through it, and this table, group 1 and etc., this is not at all needed for you. Group 3 is also not needed in page number 52. We'll go in the subtopic, that's the distance time graph. Now this thing is a bit complicated, but it's really good. Data can be represented, now they are telling something about data here. Data can be represented graphically in different ways. Two ways are shown in figure, this and this, A and B, graph chart, and one is bar graph. You can see that. Pie chart, yeah, B was pie chart actually, sorry. And the percentage, the graph has two axes or two lines drawn in perpendicular to each other. You can skip these. The first paragraph of distance time graph can be skipped. We will move to the next paragraph. There's a graph has two axes or two lines in drawn perpendicular to each other. Example, time axis, while the other is vertical line represents the distance axis. So the horizontal line represents the time axis and the vertical line represents the distance axis. Suppose you have read on a distance time graph the distance covered by a moving body after every second. How would you represent the data on a distance time graph? On the other hand, how would you read such a graph to obtain data? A couple of examples will help you understand. These are some examples. I'll just explain that in a small portion. So, as you have seen in table 6.1, that is really important. That is important, and it's really important. If you don't mention this table in your exam and just draw the graph here, your teacher would surely deduct marks. So I'll explain that in a bit short way. Two perpendicular lines in figure 6.7, you can see here, represent the distance and the time. When you scale the represented data graphically, you must mention the units. Yeah, units are really important. You have to mention the units. You must also choose a scale. In this case, for example, you could let 1 centimeter equals to 1 second on the time axis and 1 centimeter equals to 2 meter on the distance axis. This is important. If you don't mention a scale, teacher will also cut marks. So these are something bit complicated, but you have to mention this all, and this is easy. By the way, this is really easy. The body covers 3 meter in 1 second. The point A on the graph represents this. To plot point A, we mark the point corresponding to 1s, means 1 second on the time axis, and we draw perpendicular to the axis and the point. Similarly, we draw perpendicular to the distance axis at the point corresponding to 3 meter. Point A is the point where two distance covered by the body in 2 seconds and 3 seconds and 4 seconds respectively. That means that point A is the point where two perpendiculars intersect. We can plot points B, C, D in similar way to represent the distance covered by the body in 2 seconds, 3 seconds, 4 seconds respectively. Joining the points and extending the line 0 seconds is 0 meter point gives us a distance time graph representing the motion of the body. The distance time graph of a body is in uniform motion, is always a straight line. So you must think that this is something complicated and something like that, but I would explain surely. So suppose I have made a graph actually, in which I give my x-axis, that's the upward going axis, and y-axis, that's the down axis or the right side going axis, and you plot your distance like this and give a scale that is one block of the graph paper in the x-axis equals to 2 meter, and one block of the graph paper in the y-axis equals to 1 second, right? You give something like this and plot your information like this. You have to, suppose in 1 second you notice that it traveled 3 meters. So you put your dotted line in the point from 3 to point A, as you have seen in the 6.7 graph. I'll show it again. I'll zoom it, by the way. That's the 6.17 graph, and you can see that 1 and 3 are meeting in point A. So you have to draw like this with using dotted lines, and you have to similarly do that in 2 seconds 6, and in 3 seconds 9, and 4 seconds 12. So this would become a uniform graph, and you would not have any problems with this. And next we'd learn how to calculate the speed of a body from the graph. According to the graph, the distance covered in 2 seconds represented by OF is 6 meters represented by OG. Therefore, the speed of the body equals to distance traveled by the time taken equals to OG by OF equals to 6 meter by 2 seconds equals to 3 meter per second. Now let's explain this. You have to draw a right angle triangle. In 1 second it traveled 3 meters. In 2 seconds it traveled 6 meters. So the point between 3 and 1 is A, and the point between 6 and 2 is B. So we join AB, and then after joining AB, we take point 3, the first point, and join BE in the 2 second point, and it becomes a right angle triangle. That's A, B and E. For this, first you have to subtract the total distance. That's B minus E, that's 6 meter minus 3 meter, and that is 3 meter, and the time, that is 2 seconds minus 1 second, that's 1 second. So 3 meters by 1 second equals to 3 meter per second. That means 3 meter second, or 3 meters second to the power minus 1. That also can be written. I hope you understood this. And next we have some explanations, or some examples or something like that. That is not important actually. You can calculate the speed from the distance traveled by the body in 5 seconds. That is the continuation of that. And this is an important thing. The higher the speed of a body, the steeper the distance time graph. So you can draw a distance time graph for non-uniform motion also. This is a uniform motions graph, but you can draw for non-uniform motions graph. It would be something like, not an perpendicular 45-degree angle line would not be there, and something else would be there, but still it's good. I hope you understood this chapter, and we have ended the chapter here. There are some exercises here. You can get the answers also. I hope you would go and solve these answers and these questions easily. I'll show you the exercises. It's on page number 54 and 55. You can do that. Numericals are really important. You have to do that, and pause the video and note down the exercises, and just do that simply, and it would be easy. Just easy, and go and tell this to your class teacher, the physics teacher. She would be really impressed. And now I hope that you liked my video. Subscribe my channel and like this video for latest technological and educational updates. Thank you.